Good afternoon. So now here we are towards the end of the day, so I'll make the standing joke that, we're the only thing standing between you and the cocktails. So we'll try to make it lively and keep the conversation going. And it may be tough at some point to take all the questions that may come from such a large audience, but we'll do our best to make it through that. But first, I'd like to talk a little bit about where we're going with the panelists and introduce them, and then give each of them a chance to talk a little bit about what they're doing in sensors and edge computing. And then we'll plant some questions and start the conversation rolling and see where we go from there. So I will go from your right to your left. First, introduce Ray Almgren. Ray is the CEO of Swiftsensors. They're a developer of cloud-based wireless sensor systems for industrial applications. Prior to taking over as CEO, he was the Chief Marketing Officer and the Chief Operating Officer at Swiftsensors. Prior to his role there, Ray was Vice President of Product Marketing at National Instruments, where he worked for 29 years. He received his BS in Electrical Engineering from the University of Texas at Austin. Next is Justin Patrick. Justin has 20 years of successful global leadership experience in operations, manufacturing, engineering, technology, and consumer industries. He joined Itron as Senior Vice President of Device Solutions in January of 2020. In this role, he's responsible for financial performance, product development, marketing, and the overall global strategy for Itron's products and devices. Prior to joining Itron, Justin was Vice President and General Manager of Johnson Controls HVAC business, and prior to Johnson Controls, he held multiple sales and leadership roles at Carrier Corporation. He was an officer in the U.S. Navy, holds a Master's of Business Administration and a Bachelor of Science in Mechanical Engineering from the University of Notre Dame. Next is Brent Lunsford. Brent is the Managing Director at Memstronics. They're a strategic planning and advisory firm in the areas of sensors, IoT, industrial automation, and integration of smart electronic systems. He started his career with Microelectronics and Computer Technology Corporation. We know it as MCC in the Austin area, where he developed novel processes for MEMS manufacturing and heterogeneous integration. After MCC, Brent led strategic innovation at Cypress Semiconductor, Silicon Light Machines, and 3M, transforming core capabilities into emerging markets of IoT, industrial automation, and high bandwidth wireless communication systems. Brent has an undergraduate and graduate degrees in chemistry from Texas State University, an MBA from UT Austin McCombs Business School, and a focus on strategic and innovation and business model innovation. He serves as a global engagement chair for the IEEE Sensors Council and is founding officer of the IEEE San Francisco area MEMS and Sensors chapter and the founding chair of the IEEE Central Texas MEMS and Sensors chapter. Welcome, Brent. And finally, we have Scott Hinson. Scott's the Chief Technology Officer at Pecan Street, where he leads the Pecan Street Lab and directs research efforts to study the grid and climate impacts for integrating renewable technologies, electric vehicles, and software-enabled smart devices that modernize and decarbonize the electric and transportation sectors. Prior to Pecan Street, Scott worked at thin films at SIG's solar module manufacturer, where he led module packaging, performance, certification, and reliability efforts. Scott's also worked in the military, medical, consumer, and oil industries, developing power supplies, precision measurement equipment, and inductive heating technologies. Scott received his BSEE from the University of Texas at Austin, with undergraduate specializations in both communication systems and power distribution. Scott was awarded the 2015 Outstanding Engineering Award for transforming the world's understanding of consumer and community electrical usage by the IEEE Power Engineering Society of Central Texas. He's also a contributing author to Transmission and Distribution World magazine. So welcome to the panelists. So I guess I'd just like to have each one talk a little bit about, and I'll start with Ray, I guess, again. Tell us what you're doing in areas of sensors and edge computing.
Cool. Thank you very much. It's an honor to be here. Thanks for inviting us. At Swiftsensors, we make a wireless sensor system. The sensors are pretty small, about the size of this business card. They measure things like temperature and vibration and motion. And they're on a cloud-based system that communicates all the sensor data to the cloud. The typical uses for our stuff are in things like food service, could be cafeterias, could be restaurants, nursing homes where you have to keep or need to know what the temperatures and the hazardous control points are for keeping your food safe. Could be food manufacturing, that's a common application. We also do a lot of monitoring in pharmaceutical, like vaccines, obviously. Typically that would be in a small place like these medical places that you see along the road where they're given vaccines, the HEB, and they have to make sure they follow the government regulations to keep those things monitored at the right place. And then also in small manufacturing, small to medium manufacturing, where their processes and machines don't really give them the information they'd like about operational efficiency and shift efficiency. And the cost to upgrade the capital equipment doesn't really justify getting a digital footprint, where it's a lot cheaper to retrofit it with some small $100 sensors and get that data on the cloud and make some decisions. The basic benefit we offer is not so much the wireless sensors in the cloud, it's that you can monitor and create automated reports to follow government requirements. You can make better decisions and understand what your equipment's doing. And then finally, it's peace of mind, particularly with people that have perishable inventory, that if something goes wrong or is about to go wrong, you'll know about it quickly and be able to do something. You know, it's one thing to lose some inventory because you weren't sure about it. It's yet another thing to not know that you should have lost the inventory and deliver that inventory to your customer when it's spoiled. So that's the basic value proposition of what we offer, is peace of mind and the ability to automate things that employees, particularly in the food service where they don't have employees right now, can do automated and do it a lot more efficiently and better.
Thanks, Ray. And Justin, your area is quite different, so.
Yeah, absolutely. So, hey, thanks everybody for the opportunity to speak today. So, Itron tries to help utilities, municipalities, and customers conserve water, gas, and electric resources. We do that through smart meters that connect to networks that then go to software as a service and allow utilities and municipalities and homeowners or consumers to better manage how they use those resources. And we use edge computing to do that by getting that data and analytics as close to the point of use and as close to the edge of the grid as possible to augment what the utilities and municipalities are doing to manage their networks and their installations as a central function. So more to follow on that, but that's essentially what we're doing.
Thanks, Justin. Let's go over to you, Scott.
Well, I'm very different from all these groups. I work for a 501c3 nonprofit research organization. Our biggest claim to fame is our data collection around energy usage. We have a network of volunteer participants in upstate New York, Northern California, and in Central Texas. We're expanding into Detroit and Puerto Rico. We put instrumentation in homes that measures electricity usage at a circuit level at a 1 second interval basis. So we have homes that generate 10.5 million data points a day. We collect 4 billion data points a day. And by the end of middle 2022, we'll be at like 7 billion data points a day for just that energy usage, which we collect and store in perpetuity on our servers and then license out to a number of commercial and academic entities for research purposes. So basically, our data set becomes a ground truth for a lot of the distributed algorithms that end up running to determine whether or not you should be charging, or volt-var compensation, or some of these other pretty critical tasks for transforming energy usage within a residential structure.
Thanks. I think we'll come back a little later and talk about the storage requirements for all those data points and all the other data points that are being collected by the ubiquitous sensors that we see. But Brent?
Yeah, so I'm Brent Lunsford. I manage Memstronics. And most of what Memstronics does is we kind of do the full, from product development, which is the sensor development, to integrating into a multi-chip module, and then ultimately to a system and a package, and then OEM integration. And I've been doing this since the days of the MCC consortium. And I want to mention MCC in Austin, Texas, was founded by the United States government to enable the United States to leapfrog the world in technology. And that's what led to the high-tech boom in Austin. And that experience of working with DARPA and MIT and Berkeley and institutions like that is what gave me this experience. And we have been on a really fast trajectory and roadmap since then that these guys are all now realizing. And so in a nutshell, that's what I do. I have a virtual team of, I would say, world-class designers, testers, and product developers. So in a nutshell, that's what I do now.
Great,
Thank
thanks. So you've met the panelists and heard a little bit about their areas. Clearly, we have a pretty broad spectrum of expertise to cover things. And, you know, as you've seen in many of the presentations here, sensors are everywhere. And I really like Bill's reference to the Cambrian explosion. It truly has been. And not only sensors everywhere, but the applications are endless. So we're seeing an unprecedented growth in sensor technology in consumer, enterprise, smart homes, and smart cities. And you know, we have a lot of ground to cover. So, you know, I'll start with some questions and then get closer to the mic. I'll start with some questions, and then, you know, anybody that has some from the audience, we've got a microphone in the center. Please come up and join us. But I'll start with some softballs, some easy ones. So Ray and Brent, both of you kind of work in sensor development and sensor companies. You know, what are edge sensors in your perspective, and how do they differ?
I go first? Okay. Well, you know, my perspective comes from our company, which builds pretty simple ones. In terms of what they do, they've got a lot of horsepower in them, with an arm in there, of course. We don't do a lot in there right now. Mainly we get the sample from the IC that's actually making the measurement, and then package it up and get the data up to the cloud. But there's so much potential, and we've already started that. It may seem like a little thing, but it's actually a big thing. We're putting a digital out switch on our newest sensor, which means we can make decisions and do control, and that brings us into a whole new world of a lot of complexity from an application point of view. Figuring that out at the sensor is really not that hard. But for us, that's kind of a simple example, but the application complexity of putting that in the sensor, while easy for us, is extremely complicated for the user, where they go from just knowing that they have a temperature, and then on the cloud they can decide if it's too hot, too cold, you know, to being able to make a decision in microseconds and doing something about it. Now again, that's not new. That's a control system. These guys do it all the time. But doing it in a small wireless sensor that's on the cloud is a big leap for us in terms of how do we manage that and make it possible for a customer. And by the way, our customers are nurses. Not that they would want this, but a lot of our customers are nurses and people that run restaurants. So it's a big leap. But it's absolutely the future. And from our perspective, it's just about balancing the very simple ease of use that we're trying to make possible to a broad set of people with, okay, if you put this edge stuff in this sensor or in this gateway, how are you going to make it possible for the kind of customer that we have to use it without completely blowing up, not literally, but making it so complicated they have no concept of how to use it.
So Brent, staying with the sensors for a minute and the application complexities, you know, how do they work and how are they integrated?
So the way they're typically integrated today is with a gateway that is one of the key things. And I want to take back to an early example in my career where we developed a fully automated AI-enabled manufacturing system that had computer vision and the intelligence to recognize everything in the XYZ directions and how things were moving about. That was truly where you're using a computer to take in all this data and do the computation there. Whereas now we're building sensors that have the computation capability there at a remote gateway that can communicate beyond that, whether that be to an API or a cloud. But the edge is now, sometimes it's considered a computer, but other times it's the embedded intelligence that could be heterogeneously integrated into the sensor or a multi-chip unit.
So I think we'll find that the edge sensors are everything from your smartwatch to your smart meter.
Yes.
And everything around that.
Right.
Fantastic. So Justin, how would you define edge computing and why does it matter?
Yeah, sure. So absolutely. Can you hear me all right? I'm making sure I'm close enough. For me, edge computing, again, goes back to taking it as local as you possibly can and putting the analytics and the computing power in that device, whether it's a sensor and being able to take that sensor's information as well as the analytics that we're doing on the meter or the device itself. But it's more than that. It's also the infrastructure in which you have it. So it's great to have that data local and have the meters talking to themselves and seeing if there's a difference between the voltage between an electric meter or not. Also being able to transport that information back to the utility, the municipality, or even to the consumer so they can understand what is the meter doing, how are they using electricity in this case. And so it's about the framework and the complete network and then the applications that you can put on that smart meter. So you talked about it being a smart sensor. We got a Linux processor on our meters, right, to allow us to go put applications on there to figure out the different use cases that customers need, whether it's like a meter theft bypass. So someone's putting electricity into their home in advance of the meter, which is pretty dangerous, by the way. But, so making sure that the utilities or the homeowner understands what's happening with what they're consuming and then getting it back up to the utilities so they can go and react to it. So it's the whole spectrum for us.
It's the whole local system, but then there's some transmission back
Correct.
to
Yep.
the cloud or otherwise for further processing.
Correct, yep.
Yeah. So I'll ask any of the panelists to jump in on any of these comments if you have others. But Scott, I'll ask you, what level of compute are you seeing researchers use in their edge computing? And is it just signal processing? Is it machine learning? And what's the extent of it?
So for the energy world, right, so to make decisions on demand response events, trying to get thermostatic loads to follow reg up, reg down signals and things like that, the compute power that is currently needed, frankly, isn't that much. We use Raspberry Pis like they're going out of style. I mean, we're putting them in houses like crazy. We have every once in a while a specialized application where we might use something a little bit more powerful. But even the most advanced control models that for an ARPA-E research project that we're doing with University of Michigan, the processor load at full bore compute on that thing is like 12%. So for those sorts of applications, there just isn't as much need for a lot of processor. We do need it to be reliable. We need it to be super tolerant of temperature range, things like that, because we can't always guarantee where we're going to put it. But we don't necessarily need a tremendous amount of horsepower.
Interesting. I would have assumed there was a lot more data at the edge being processed than 12%
Well, I mean, for
Raspberry Pi.
for other applications like previous keynote, right? Like my kids and I are really used to yelling at Alexa right now and asking for things and different levels of digital signal processing. But when we're looking for, we're putting some PMUs in folks' houses at this point, and our data collection points are going to skyrocket when I do that. I haven't told our data manager we're doing that. Hopefully, he doesn't see the recording of this before I can talk to him. Even then, it's BeagleBone Black, right? We've done some stuff where, for limited periods of time, we've used some of the Cortex M7s where we've sort of dug into the DSP to spot transient events and then start to extract some information around those. But those are sort of limited one-off things. If you're looking at the machine learning even and prediction around, solar production, and do you store that energy in a battery or position that battery for a discharge, it is not as much processing power as you might think.
Well, the energy and metering applications is a really great example, and I think we're all recognized that in the past 18 months we've been going through this digital transformation. It's been accelerated, especially in our home applications. Energy is not only industrial, but it's in the home. It's a consumer element to it too. But it really seems to be blurring the lines between information technology and operational technology. So I don't know, Brent, could you comment on what's the impact, the operational technologies aspects of it?
Yeah, and my comments may be generic or obvious to all of you, but think about 20 years ago, IT was IT, and now these technologies are turning into the operational technology that controls or enables you to optimize the operation. So they translate to money, whether it be losses or savings or money on the table. But to me, the way it's all converging into operational technology now, it is a key to the future.
Okay.
So Dave, I'm going to jump in on
Yeah,
that
please
as well.
do.
Yeah, so the other thing that edge computing does is allows, in my part of the industry, utilities to understand where there might be a break in electrical connection or a line down, and it can tell them where it is, and so they can roll the truck exactly to that location rather than trying to guess where it is on the line. Or another example is where you have over or under pressure in a gas line, right? It allows you to understand what that dangerous condition is, and you can actually shut that off. One of the other great things about this edge computing is that, let's say when we had the big snowstorm and we lost power for however long it was, you can cold start up across the different transformers slowly. So like you bring one or two houses, 1 or 2 meters back on, so as you bring everybody back up, you don't overload the grid and crash it again. So there's a lot of that distributed knowledge out there that helps them to go do that. So it saves them from a lot of those issues.
Yeah. So those are good examples of, the break in the transmission line or gas detection. Those have been around for quite a long time. When did the real smart electronic systems that are now being embedded in the home take off, and how and why?
That's a good question. So I'll speak from Itron's perspective. We've had smart meters in the field now for, it's about 2018, doing distributed intelligence, and we've been working to get the rest of our platform of products to be in that same level of edge computing. If I think about electric devices, we've got over 3 million distributed intelligence electric meters out there today, and they all have about 2 to 3 apps on them as well. So some of the use cases that I talked about, whether it's high impedance or whether it's broken neutral or whether it's the meter theft bypass that we talked about.
Yeah.
And we've got a number of different customers that have been doing it as well. And it's these use cases of how do I know that there's an issue out in the field? How do I know how to go fix it quickly? That really drives the return for them. So.
Great. And we're talking a lot about the edge computing. Of course, that's the topic here, but we also talked some about the cloud. So I don't know, Ray, could you give a distinction between edge computing and cloud computing from a device perspective, and how is that related?
That's a good question. We're driven in our business, again, I think you can tell our applications technically are fairly simple. The real reason that we distinguish between edge computing and cloud computing is this really nasty problem we have called a battery. So when we're in design meetings, the only thing that matters is how long will those batteries last for this sensor. And it may seem strange, but it turns out, and it's kind of similar to Scott, the MPU or CPU usage in all of our stuff is microscopic. You can't even tell. Like, we're doing nothing relative to what we could be doing on the sensor because of the battery.
Mm-hmm.
And if we didn't have this battery problem, we would be doing everything on the sensor and a lot more on the gateway, although it's powered, so that's not a relevant problem. That's more of an infrastructure problem. But for us, it's not really answering your question, Dave, but it gives insight into, well, why wouldn't you do everything on the edge? Why wouldn't you do everything in the sensor? Well, we would. But that poor little battery, which the only thing that matters for us is how long that battery, if we could tell the customer, you won't have to replace this battery for 5 years, they'll buy it. If we tell them you got 6 months, they'll never do business with us.
Buy it.
So in a theoretical level, there isn't a lot of difference. Okay. And there's plenty of processing power in our module. We happen to use Bluetooth on most of our sensors. There's plenty to do all kinds of wonderful things, but we just choose not to.
Well, that's an interesting distinction. And Brent, you've done a lot of work in heterogeneous integration. Are you seeing any type of energy harvesting devices being integrated with sensors that harvest from the ambient environment?
Yeah, there is a lot of energy harvesting that's been going on. I did want to make a comment about when things started to sort of change. It's when we had this explosion in understanding that we can miniaturize things that we call micro-electromechanical systems and sensors, but we can miniaturize mechanically moving parts down to a microchip level. And the smaller and smaller they get, the less power they consume and the more reliable they behave. And it was about 2007. We all had mobile phones prior to that. When we integrated MEMS and sensors into a mobile phone, it became a smartphone. Essentially, we're doing that across all these industries now. I wanted to sneak that in. What was your question again?
Energy harvesting.
Energy harvesting, yes. So for me, it began with solar energy harvesting, photons. But now we're getting down to where we can harvest vibrational energy and just about most of forms of energy. Even thermoelectric energy, just heat that's dissipated from a chip or from a surface. This field of energy harvesting, in my opinion, is really starting to take off right now. There have been a few MEMS startups that focused on harvesting the energy from ambient, whether it be photons or heat. But if you look at that field right now, it's really taking off and it's converging with flexible hybrid, even wearable sensors that require very little power and some with even no battery power.
All right. So then I guess, Scott, I'll ask you, given that some are driven by battery life or whether they can energy harvest.
We feel your pain. We did a water sensor with batteries.
Yeah, but what applications might need edge computing versus those that need cloud computing?
So, the stuff that we're doing is a perfect example of this, right? The need to have the comparative data for hundreds of other homes at 10.5 million data points a day is in the beginning for the algorithm development, and even that need is reducing as ML AI applications start to become more and more advanced. But once you've determined that, like the project we're doing with the University of Michigan, like their fanciest Markov controllers that they're using in there are reliant only on the local data and the general direction signal that they get from the centralized controller. So they're given hey, for the next 15 minutes, we want you to ramp like this. This is your sort of deterministic environment you can choose from in terms of your decision to turn that air conditioner on or off. Go. And that controller is not going and comparing to a whole lot of other houses. It doesn't know what's happening in the other houses. It only knows what's happening for itself, and then it makes its decision, and the overall controller can then take a look and say, okay, everything in aggregate is moving the direction that I want, but it doesn't need to get all that data back, right? So we're seeing sort of that dividing line of back to the Itron example, right? Years ago, we started putting these smart meters on the side of these houses to reduce truck rolls for meter reads and things like that, but there wasn't the applications that he just talked about running on those meters. So for all the talk of smart meters, they weren't that smart, but now they can be, and now they actually have some useful applications on them. So that's sort of where we see this headed. We're hoping it actually takes off very quickly in terms of control and managing energy usage and savings within the home. We hope there's a bunch of things to control: batteries, air conditioning, solar, things like that, because there is an awful lot of opportunity for overall emissions reduction if we can manage that load to follow the generation versus the way it works right now.
Excellent. So remember, if anyone has any questions, please come up. That's an earnest point. So edge computing can be deployed without the cloud, but there's probably value in sending data back to the cloud for more machine learning. Justin, you have any comments on that?
Yeah, so again, like I said, the local edge computing allows for quick response, quick understanding of what the conditions are in that meter or that application. I think that the normal meter read is anywhere from 5 to 10 minutes if it's on the centralized location. And so that localized information will allow the call back home and say, hey, we have a problem over here, and allow for the utility or the municipality to understand that better. It also allows us to provide that data to consumers in the form of some of the applications that we have. So we can do disaggregation of the energy load in a house. So I can understand whether my refrigerator's running too high, my AC's running off, and that there's something wrong with it. It also allows me, if I'm on a set budget or on a prepay meter type of program with the utility, how's my daily consumption going? And if I need to, I'm going to stop watching TV, or I'm going to turn my thermostat up so that I'm not using as much energy. One of the other applications we do is tracking how senior citizens use their energy throughout the day, and if there's something that spikes off the wrong way, it allows healthcare professionals to go in and check and see, hey, is there something wrong in that situation? Now that data is all secure. It's all cybersecurity. It's not tracking people per se. It's just understanding the habits of either the consumer or the folks that are in those applications and making sure that they know what's happening. Yep. So to your point, Scott, about better consumption, better usage, better understanding how we're using our resources.
I mean, that's been our challenge for years, right? Like I started Pecan Street 10 years ago. I went to a conference. It wasn't this one. This one hasn't been going on that long. And I remember somebody talking about, well, the home will do this, and all this stuff will happen automatically. And I'm sitting here 10 years later going, we're kind of still waiting for a lot of that, right? And it's all possible, but instead of having, thermostats with proprietary APIs that the utilities can buy into, we need better access to these things so that you can, the research world and B, the commercial world can get in there and say, okay, we need it to look like this and behave differently and do it all automatically, and the homeowner doesn't notice.
So we've heard it's going to happen for a long time. But
I'm not going to hold my breath because I'll be passed out on the floor here.
Will we move to a fully automated grid balancing for all loads, faults, frequencies, et cetera, in real time?
I mean, they're already doing it, but there's so many ways that Pecan Street did a program with Austin Energy where we put residential energy storage in folks' homes. And for, a year period, the batteries were utilized like 108 hours. Think about that, right? Wow. And even with even with that level of utilization, you could pay for the batteries with the economic impact that they made in like 2.5 years. But you're leaving a lot of potential on the table, and the newest lithium-ion technologies will typically age out before you cycle them out, right? As they get better and better and better, it's harder and harder to get a battery to die because you've cycled it up and down in charge level. We just aren't moving fast enough to get those sorts of changes within the house happening.
So what would be the factors that would drive an increase in the adoption rate? Well, let me finish this question. To follow on with that, what would be the factors that would drive the increased adoption of sensors and edge computing for energy applications?
Economic incentive for the homeowner.
Okay, just that.
The homeowner is so insulated right now from, if I go to any residential consumer, and our volunteer participants are well educated in energy, right? Like when the winter storm was happening, 2 days before, when it was starting to hit the news, they were calling us and saying, what can we do to help? So they were aware, right? That was not the normal application, or that's not the normal person, right? But if I ask them, what is your contribution to peak pricing? Or what is your contribution to, they're not gonna know, right? Like that, in a light commercial setting, what part of your bill is demand charges versus energy charges? I don't know. They're not gonna know.
Great. Question from the audience.
Yeah, so I'm curious, you guys are talking about the residential side of everything quite a bit. Curious if you're looking at the commercial side at all. And if so, like what? Because that's if we're talking about turning, finding ways to save energy, commercial buildings are huge concern.
I get to punt very easily on that one. We concentrate on the residential side. We've started to. We're looking at sort of campus type facilities for HBCUs and some other sort of light commercial, but I don't have a good answer for you.
Well, so I would say that we're doing the same things on the commercial side. I've just been speaking to the residential because that's where Scott's focused and it ties in with it. But we do the same thing for commercial customers, letting them understand how their plants and their locations are using energy or gas or water and figuring out how to better manage it.
And Itron has capabilities for monitoring like site-wide behind the fence,
yep.
or behind the meter as well, right?
Correct.
Like you've got some commercial technologies for microgrids and things like that they can tap into too.
Yep, exactly.
I think it's safe to say that all corporations right now are looking at your question. I mean, and take it back to a local example. When we had the winter storm, you may have seen the news that we had a Google building and a Facebook building that were completely lit up while we were out of electricity. This kind of shook everybody up in the United States, and it resonates with what's going on with the world in sustainability. So all corporations have a board level initiative right now to address what you're talking about. And so do some of our panelists. They mean, like Itron, you're talking about residential, but you're a B2B company, right? So you're dealing with it at the business level, the corporate level. Anyway, go ahead, please.
Great. Any other? Catherine?
Hey, Catherine Grego. I work in public and affordable housing, and so just to pull it back a little bit to residential, many corporations, power-intensive companies are clustered together, and many low-income and affordable housing units are not located near those. We hear IoT everywhere, and I'm just curious, thinking about emergency operations, water and utility provisions. Many folks in many cities are sitting on a physical infrastructure, broadband infrastructure, a sort of substrate and personal technology stack that may not enable sensors and edge computing. Do you see a future where sensors and edge computing will provide more equitable distribution of services? Or do you see a future of fiefdoms that, sort of sensors and edge computing fiefdoms that exacerbate inequities?
I will take that one. So just this summer, Pecan Street launched a Center for Race and Energy because we see that exact thing happening, right? For instance, I have it's older now, but a Chevy Volt, and I have realized that because 98% of my driving, I'm not out of my 30-mile range. And I have realized this is the cheapest car I have ever owned. I have paid less than $2,000 in maintenance over its 10-year lifetime because I've basically put a set of tires and one oil change into it. It's not even asking for the oil over time. And I'm like, are you sure? And the engine tells you, hey, I need oil. But I could afford that outlay, right? And this is not going to be the case. In community housing, there's no spaces to charge. There's no infrastructure for charging. There are a lot of programs being designed right now to figure out how to address this. But a lot of it it's still not the same. It's not equitable, and it's really frustrating. I don't know what the answer is, but I do share your concern, and we're looking at it. I mean, that's one of the reasons why we're doing the HBCU toolkit, because during the winter storm, there were so many college students really stranded in a lot of trouble. And so that we reached out to some of these universities in Texas, right? And then we realized there's going to be issues with hurricanes and things like that for resiliency structures that we could put in there.
I'll take it in a maybe slightly different direction. I would say that depending on how the municipality or the utility installs the smart meters, they're agnostic to where they're placed. And as long as you have a canopy that's able to read that, you don't need the homeowner doesn't need IoT to be able, or even network to be able to do it. It automatically goes back to the utility because they still want the ability to read those meters and to take action if they need to. So I think that there's a little bit of that in there also.
That's a good point. The electric utility is actually in a spot for communication that is enviable for anybody except for maybe cell phone companies, right?
Mm-hmm. Yep.
Electric utilities have very robust communication systems.
So relative to that, then, the data going back to the utilities, is process data transferred back, or is all data transferred back when it comes to edge computing versus what they're doing with AI or machine learning at the utility, let's say?
Ooh, that's a good. I think that varies wildly by utility. I mean, I was just on the phone with some utilities today, talking about how they have substations with paper chart recorders. Still, so yeah, I think it varies very wildly of how much they're bringing back. Like Austin Energy brings a ton back, an absolute mountain of data back, but that's not true for every utility.
Yeah, it depends on how sophisticated the utility is and what they're trying to do with it and what kind of front end or head end system that they're using to manage their network. Mm-hmm.
Yeah, and that kind of relates to your comment earlier about the disaggregation of energy within the house. So you have a smart meter and it can look inside and it can determine whether your refrigerator's kicking off at weird times or not. And how does it distinguish? Do each of those devices have to have an edge sensor as well? Or does it just do it based on energy draw at specific times?
Voodoo. No, I'm just kidding.
That's what it seems like to me. Magic.
What it does is it'll measure how much consumption is at certain points in time, and there's profiles for a refrigerator, an electric oven, or a stove, and it'll figure out what's happening at different times and then be able to kind of learn as it goes along what's happening in the house.
Fantastic. So in the last presentation, we heard a little bit about sensor fusion. Ray, could you comment on how sensor fusion is deployed at the edge?
Well, that's That, to me, that's the real promise of the IoT as it relates to sensors. I have a kind of a theoretical view of that, but because of the cloud and the edge, anything can be fused together. Whether it's done, in a single package where you have multiple sensors and they're doing the edge computing and figuring out, whatever water usage without, being intrusive and having some nice DSP or whatever that figures it out between sound and vibration and whatever. Or if you're doing it all on the cloud and you've got 4 different sensors that are, whatever, and it might take an hour. It kind of doesn't matter. But to me, at least I feel like sensor fusion, though it's a little bit of a nerdy term and the customers don't care about it, but the ability to use that information freely between the sensor through the gateway up to the cloud and make really cool decisions about things that otherwise would be completely impossible is what's going to really add significant value. I mean, just knowing what the temperature is, that's cool, and we can help people not, spoil their meat, but there's so much more potential, and that's where I get the most excited about the future, is because it's just unlimited. I mean, the smart car is a good example. I mean, that's way too expensive, and there's way too much, IT in that to sell broadly to, people at a very low price. But it shows what's possible, where you can fuse this stuff together and make unbelievable decisions in every aspect of every business and every residential house.
So sensor fusion is a nice marketing term. But what about heterogeneous integration? Isn't that how they're all brought together, Brent? And how does that work?
Yeah,
And what are the challenges, I guess, yeah.
So sensor fusion, yeah, to me, it's heterogeneous integration today. Maybe 10 years ago, it was individual sensor chips or sensors. But being able to integrate these, sensor chips on top of an ARM core processor, where you've got very little distance in between the sensing and the processing and the transmitting of data. That's what's really going on, and it's also converging a lot of multiple disciplines together, and sometimes that's the reason it takes so long. We're kind of still in the infancy of this, and I know we hear that a lot, but the sensor fusion and the heterogeneous integration, that's what's going on at the high level, and we're starting to see this now happen at the consumer level or the healthcare sensor level, remote monitoring of patients and things like that, where you don't want to have 10 sensors on a patient. It's all integrated into one. Yeah.
So with that data being collected on the edge, does it all, and it's being processed, in Raspberry Pi or what it may be, does it also require local storage, or is the data transient enough that it doesn't require any significant storage?
For us, that wildly varies by application, right? So for our ground truth database, we use devices that have storage because we will lose connectivity to them fairly regularly, right? We depend on residential broadband connection to get to them. But they will store anywhere from 3 to 11 days worth of data. So we reestablish connectivity. We don't lose, we don't have data gaps. We have a ton of homes with like 99.9% data completeness. But then we have, I foresee the end applications for a ton of this stuff, measuring all sorts of things, and then making a decision, and then sort of remembering why you made the decision, but you can forget all that data. And you're just not going to need to store it all that much. That doesn't work for that ground truthing portion, the research portion of it, but for the end application, that's a perfectly viable way to do it.
Great. And Justin, I'd like to come back to you. You commented earlier, and I don't want to do it too deeply into it. You talked about security of the data. Does edge computing make the data inherently more secure because it's being processed locally? or is there local encryption, or are there aspects of that security?
Yeah, so I wouldn't say that it makes it more secure. It comes down to for me, right, how do we develop the safety protocols or security protocols, both in the edge computing or in that Linux processor, along with the way that we have the connection back into the network. So all of our devices have a very unique identifier, and if it goes on to a network that doesn't recognize that identifier as being on that network, it won't share the data. And then we take that even further along. We're using ISO 27001, 27002, NIST standards of 853 and IR 7628. I don't know those off the top of my head, but I had to have them here. So we build that into the devices, and then we build that into how our network works. We do testing to make sure penetration testing or, external and internal, so that we do have all that built into the systems as well. So it's not a matter of whether edge computing makes it more or less secure. It's how does the manufacturer or how does the system work together to make sure that, it's like your iPhone, right? If I'm going to allow it to use the location services or not, or whether I allow it to connect to my contacts or not, we have that same level of security within the devices and our networks and our software as a service.
That's a good analogy, makes it comprehensible.
We do a lot with life safety because we put these batteries in, right?
Yeah.
And stuff like that. We do a tremendous amount of work on the cybersecurity side, but then because of the life safety criticalness of it, we have very, very, very dumb non-communicating hardware fail-safes. Things like temperature cutoffs. So if you, for instance, if you're charging and discharging a battery rapidly, it will heat up. There are internal losses. The sun shines in Texas, batteries get hot in August. One could, in theory, come up with a scenario where you started to exercise a battery, discharge, charge very hard in August and torture that battery. Well, we said, all right, we're going to solve that, and basically the disarm button, the no operate button, we put a thermal switch in it, in series with it. So, and that was on the back of the battery where the heat sinks was. So if the heat sinks were within 10 degrees of their cutoff, which is a pretty healthy safety margin, battery's not going to operate. And nothing you can do about it. I don't care what communications you have. So there's ways around that.
All right. So we've heard a lot about the edge computing and cloud computing, ends of spectrums. Are we seeing any fog computing implementation?
Yeah, I mean, to do the Markov model training for our stuff, I would call it almost that, right? A little bit of both. Okay. So.
All right. And I guess, we're running close to time, so if there's any final questions from the audience, please come up. But I'd like to just go across, there's a big infrastructure bill that's out there, and if you were writing all the checks from this bill, what would you buy? Ray?
Haven't thought about that. Well, if in the self-serving way, obviously we need communications all over the place so that we can easily deploy, whether that's the comm systems or the broadband systems. I'll try to leave it narrowed on that. There's all kinds of things we could talk about that are important to make our country better. But as it relates to IoT, that strikes me as probably our biggest challenge is the bandwidth. And it probably wouldn't work in the infrastructure bill, but we need better batteries.
Justin, same question.
Yes, so I wouldn't buy anything. What I would do is work with utilities, municipalities to make the rate cases that allow them to put in distributed intelligence systems. So putting in more smart meters, networks, and software as a service so that we can, put that agility and safety and security into our grids today so we don't have another snowstorm incident.
And done properly, it pays for itself.
Correct. Yep.
Yeah. Brent?
Kind of building on what you just said, the remote monitoring and controlling systems along with the increasing broadband across, I'm going to use North America as an example, and then maybe coming with the new low Earth orbit satellites. I'm trying to stick to our topic here instead of throwing in roadways and bridges.
Sure, of course.
But we do have a lot of things to spend that money on. And it does seem like, I'd like somebody to say something if they disagree. The low Earth orbit satellite system that Elon Musk has deployed part of, that might bring broadband, but that satellite broadband, my concern is that might be too expensive to serve all of humanity.
Scott?
We are very strong proponents of electrification of transportation and electrification of, frankly, large swaths of what is currently not electrified in the home. We just did a study where we looked at our participants and said, okay, for the homes that are mixed fuel homes, what would it take for them? What percentage could electrify right now? We have noticed that there were some natural gas lobbyists that seized on the price tags, which was one of the fastest reactions we've ever seen to one of the reports that we've put out. But they missed the point that roughly 50% of homes right now are already in a position to do it. And even if you are, which was literally the final paragraph of the report, so I don't know if they missed it. I think they just left it out. Or maybe I'm just being really jaded in the afternoon. But yeah, I think electrification of transportation, if I were writing those checks, electrification of transportation, electrification of residential, and electrification of legacy buildings, which is a really, really tough thing to do because, and this goes back to that market structure issue right now, there's really no way to get paid back if you don't have the money up front. And that's a weird way to say it, but unless you have a bunch of change in your pocket and you're sort of willing to let it go, the financing mechanisms that are available to folks right now, even with PACE financing or something like that, make it really, really tough.
Thank you. And unless you have a question, I'll close out the panel.
I do have a question.
No questions. You're holding up.
And I want to thank you all for being here today, and if you were here yesterday and you're going to be here tomorrow. So rumor has it that 50% of the vehicles are going to be electric by 2030. That we're going to control climate change and we're going to make buildings efficient. That 10,000 private networks are going to be built on Wi-Fi 6 and 7 and LoRa and Wi-Sun and Wynomia and WirePass and all kinds of things. And so do you guys believe that as we move from 6 billion devices in the planet to 300 billion devices that require sensors and IoT and processing, do we really have the systems and the tools and the capability, or we're just getting into a something that we're uncharted waters? I mean, can we really deliver 300 billion things and connect them?
I share your concern. You may know of the Trillion Sensors Summit, or the Trillion Sensors calculation done by Janis Bryzik out of Silicon Valley. I am concerned that we're going to be monitoring and sensing too many things. And it's great to come up with these visionary applications and things like that, but we need to be pragmatic. Electrification is an important point that hasn't been much of this discussion, or perhaps it has. But I do share that concern with you.
I mean, yeah, I'm concerned too. As I said during the panel, right? 10 years ago, I was at the Omni, and there was this dream of this automated house and still waiting. And the thing is that there's plenty of smarts in a modern refrigerator. There's microcontrollers in there, right? There's plenty of smarts in these devices. It's just they're not talking to each other right now. The Pecan Street twice in its history has deleted data. Once was because we asked for some de-identified anonymized data from a water utility, and the water utility shall remain nameless, but they sent us like billing information with social security number and addresses. And we were like, I can't have this, delete. The other time was for a thermostat that a lot of people own, that started off as a small company and then got purchased by a very large company. And they had, sort of hobbyist access to their API, and we had a bunch of data off those thermostats, and we had to delete it because we got they noticed that there was one entity accessing about 500 of them, and we got a cease and desist, and we're like, well, we're 12 people in a nonprofit, we can't fight that, so we deleted that data too.
Any other thoughts?
Yeah, I'll share a thought. We're on the pragmatic low end side of it, but I absolutely love that there's all these bold ideas and a lot of deep research that will ultimately lead to something. I don't think it will fall on itself. It's so hard for us to even sell to some of these customers because they don't get it yet. And so that's going to ultimately be kind of the governor that keeps this from going nuts. And I'll leave you with an analogy, which I think is timely because of the week that we're in. So right about this time of year, every college that has a football team plans to win either their conference or their national championship. And none of them do, except one, right? And that's fine. It's that vision and that goal to win that thing that propels them forward, and ultimately someday they'll probably win, which is great. But that's why I'm not terribly worried and just thrilled that we got research groups and others that are fighting the fight up there, paving the way so we can sell some product.
Yeah, I can't top a football analogy at this point in the day, so. Thanks.
All right, well, thank you everyone for staying with us, and thank you very much to the panelists, and tremendous amount of expertise here. I know they're set up and ready for you next door, so if you have any further questions, we'll be around. Thank you.